So we will start with Leo Vigoda, and he's right now working at IANA. He used to work at RIPE NCC, and he will talk about the analysis of PRT queries for IPv4 addresses and reserved for future allocation. Leo, please.
Hello. I concentrate in my work on looking at IP addresses, and I came here to the last NANOG, made a little lightning talk in which I said, hey, we've got lots of people telling us that these unallocated addresses are in use and that's a bad thing, and reported it to you and went away thinking, I just told you there was a problem, but I didn't really give you very much data. I just gave you some anecdotes and pointed at a couple of websites, and that isn't very useful. So I went away, did a little bit more thinking, and came up with a method, hopefully, of how to measure unallocated IPv4 addresses that are in use. It's not all the addresses, but it's a view. So I'm going to talk about what the problem is, what we're going to try and measure, what we can't measure, what the results are, and then talk a little bit about going forward. So the problem, again, to recap, is all unallocated unicast address space will be allocated. There won't be any /8s left in the IANA free pool that remain free at some point because we've all switched to IPv6 and we've taken the IPv4 off our networks. Unfortunately, the move to IPv6 isn't going to be that fast, and we're going to need all this IPv4 address space. The problem is that some networks are already using this address space, and that means that there are potential addressing conflicts when you've got multiple networks using the same addresses and all sort of thinking that they should be using them. So that's the problem. And we have tried to measure it basically by looking at DNS queries received at LRoot for the addresses that are in these unallocated blocks. The root name servers provide the DNS service for inadra.arpa. If a /8 is not allocated, it's not delegated, therefore the queries are going to come to the root. We run LRoot so we can go and do some measurements. And so we can hopefully infer from this a little bit about which parts of this unallocated address space are in use, and maybe even how much. What we can't measure is the people who have reasonably well-maintained networks, well-run networks, but those networks don't leak. We're measuring people who leak. People who don't have a split horizon DNS, people who don't have egress filters, people who sort of want to run a private network but aren't doing it very well. That's what we're seeing, that's what we can measure. We can't really legally measure anyone who's running a private network and using this address space and doing it so well that we can't see them. That's what we can't see. I don't know how big that slice of pie is. It could be really big and it could be quite small. I'm not sure if there is a way to measure it. If there is a way, then please let me know, because I would be very interested in that as well. These are the initial results just taken from one day, although, to be honest, looking at the big picture, it doesn't really change all that much. This is all the queries we got for inadra.arpa. And as you can see on the left-hand side, there's a long blue line, which is considerably longer than all the other blue lines. And that's an outlier of lots and lots and lots of queries. And then it sort of curves down quite steeply and then shallows off. And right down on the right-hand side, you can see that there's some odd-looking names. If you look down on the x-axis, and they're sort of rubbish names in inadra.arpa that for some reason people send queries to us for. Not entirely sure why, but we do know that the roots get all sorts of rubbish thrown at them, so it's not too exceptional. But this is what the big picture looks like when you look at the distribution for all /8s. And the most exciting part of this is the stuff on the left-hand side. So if we take a closer look at the stuff on the left-hand side, we can actually start to look at what's up there at the top, and is there anything that's problematic. And first off, we've got 222/8, which is allocated to a PNIC, and I don't know why it gets such a lot more queries than the other /8s. It is odd. It was suggested to me that it could be legitimate DNS lookups performed by mail servers, because there's a lot of mail that comes out of 222/8. I don't know if that's the case. I don't actually run a mail server, so it's not something that I can tell. It could just be one machine that's going crazy and sending us a hell of a lot of queries. We haven't actually done that investigation, but we could chuck this away and normalize the data, and you would see a slightly different curve. 10/8, that's not particularly weird. We expect people to leak 10/8. I'm sure it happens quite a lot, and it's right up there near the top. 0/8, which is this network, and also it's not too weird that that's leaked. And then we've got 2/8, which is unallocated. It's quite near the top. I think it's about the 16th from the top. And obviously, you've got 10 and 0 in there, which can't really be used anyway, so you could sort of make it too close to the top. It's starting to look a little bit odd that we've got unallocated address space, which is so close to the top in this view, at least on L. So this, now we need to go and look at more data, more days, and take out all the allocated stuff anyway, because the allocated stuff we don't really care about. So this is the curve that we get, and even though I've taken out all the allocated stuff, you still can't see the names because there's too many entries. So I created a top 10 just to make it easy to read. And you can see that 2 is there at the top, and then 1, and 5, which I spoke about when I was here last time, which is that Hamachi VPN service. 100 is there at number 5, and that's interesting. You may have noticed that we allocated 2/8s to Aaron last week, and the next /8s that we were going to give them 100 and 101. But because we saw 100 on this list, and it was so near the top, we thought that's probably not a good choice for Aaron, well, actually for NRAR right now, until we've got a better view of this problem, because it's possible that we go and allocate those /8s to Aaron, and then Aaron gets lots of calls saying, hey, we're having problems with this address space, and Aaron's customers, the operators in this region, have lots of problems using that address space. So that was why we didn't use 100 in, well, this round. But we've got a view now, the top 10 over a 30-day period, which is the 30 days ending on Sunday. And I went and had a look at this because when I went and pulled these statistics on Sunday, I also went and looked at them and compared them against the statistics I used when I presented this work at the ESNOG meeting in Madrid a couple of weeks ago. And it turns out that the data aren't really all that static. The order of domains in the top 10 changes, and domains join and leave the top 10. So what we've got here is we've got a side-by-side comparison of these two periods, 28th of December to 26th of January, and 19th of January to 17th of February, two 30-day periods, and there is a little bit of an overlap. And what we can see is 2 and 1, they stay at the top and they stay in the right order, but we've got some /8s that rise and some /8s that go down. 5 and 23 rise, 127 drop, and we've got 4 new entries. And it looks just like the top 10 you used to listen to on the radio before radio became rubbish. So we've got all that movement in there, and what this shows me, or what I am inferring from this data, is that it's not static. There is some movement here, and at this time, I don't really know why, but I do know that we want to do a little bit more work on this. We want to find out what's going on. So, what we're not measuring at the moment is we're not measuring the query source address and the AS number that we could get from that. It would be a possibility that we could go and collect this data. It's not difficult to collect. And then we could go and say, you're querying for this unallocated address. That probably means that someone in your AS is using that address. Maybe we could go and inform the people operating that AS that they've got this going on. It could be causing them a problem. But before we do that, we want to actually go and do a little bit more work. So far, we've only been measuring from L root. I've spoken to other root operators, and they are, in theory, happy to share the data with us so that we can get a better view of the situation. It turns out that I'm not really a proper researcher. I'm just someone who noticed a problem and wanted to take a look. But to do proper research, you need a set of skills that I don't have and that ICANN doesn't really, it's not really set up to do. So what we would like to be able to do is merge in data from other root server operators who've got nodes in all sorts of different countries around the world, in different cities, at different internet exchanges, and we would then get extra data. We would get data about whether the query was received on a global or a local node, which city it was in, who peers with that AS, all those sorts of data. And someone who really knows how to crunch the numbers could then actually do some really useful analysis. It's a big job. So what we want to do now is we want to look at whether we are going to try and get some skills to do it in-house or we're going to farm it out. But this is clearly some work that we're going to need to do a little bit more research on, so that we can combine the data from L and K and all the other root server operators that are able to share the data with us and get a better set of information that we can then present, and then hopefully use this data to at least pre-warn people, possibly help get some stuff fixed. That's ideally what we would like to do with this, and that's the end. If anyone's got any questions, then I'll do my best to answer them.
Good morning. Hi, thank you. Louis Lee, Equinix. Thank you. Louis Lee, Equinix. I wanted to find out if you've looked to see if any or most or all of these in the top 10 are in the global routing table.
No, I haven't. I probably should, but I was just looking at reverse DNS queries at the moment. But that's something that I should do, I suppose, yeah.
Thank you.
That would be what a proper researcher would do.
Leo Bicknell, ISC. I'm wondering if you looked at the source of these queries to see if, perhaps all of the queries for a particular /8 were coming from 1 or 2 resolvers, which might indicate who was using them internally.
No, I would like to do that. I want to gather all that kind of data. Well, I say I want to get someone else to do it because I don't really think it's something that I would do very well. But yes, I think that is exactly the sort of thing that would make this, rather than just a sort of, isn't this an interesting problem, to how can we help? And yeah, it would be good if we could go and do that and help. One of the issues I've discussed with John Crane, who is responsible for L, is there are some privacy considerations handling all that data, sort of taking the query address and then turning it into contact information for someone. So before we go and do that, we need to think it through very carefully, and I'm sure that the other route operators would also want to think through very carefully and maybe get us to sign stuff before they went and shared that data with us. It's the sort of thing that if we did it well, is you know, it would be good, but we don't want to leak private data too much.
Keith Mitchell, OARC. Yes, it's interesting work. Thanks, Leo. Just to point out that we have a lot of the infrastructure for gathering and sharing and also legally protecting DNS data within OARC already, and we have 11 of the 13 route operators, including yourselves, as members. So, you know, we're very happy to help facilitate what you're doing.
I think we do want to work with OARC to share this data properly and go and do this research. Well, when we get someone better than me to go and do the research. But yes, I totally agree.
Hi, Alan Larson from Switch and Data. Have you considered further instrumenting to attempt to determine the level of noise queries on what would be considered allocated or legitimate address space to determine sort of a baseline noise floor below which you probably shouldn't pay any attention to these?
I've not given it a thought. It sounds like a very sensible thing to do, but this is pretty much raw data. This doesn't have any data cleaning.
Thanks.
Hi, Dwayne Wessels from the Measurement Factory. One thing that I think to keep in mind is things that make DNS queries sort of have different behavior when something exists and when it doesn't exist. And so, in some sense, looking at the root is the wrong place to look, but in the other sense, it's the only place to look because, for example, you know, some of these zones like 0.initer.arpa don't exist anywhere, right? So it may be worthwhile to, at least temporarily, make those exist and collect data on those servers, in addition to the roots.
So actually start serving empty zones for 0 and I hadn't thought about that. Yeah, sounds like an interesting idea. Yeah, that's the sort of thing that real researchers think of, and I didn't.
I've got one. Troy Jessup from the Utah Education Network. I'm just wondering whether you've considered the possibility that the 1 and the 2 and the 100 networks, the reason why you're seeing such large amounts of queries against those are because of the miscreant or the malware that's out there that starts at 1.1.1.1 and goes through the internet and actually just does the reverse queries on those IP addresses. 100 is also one that we see as a great starting point for the miscreant community when they're creating their scan blocks. So just a statement.
When I go and look through our abuse mailbox, we do seem to get a disproportionately high number of complaints about 100. And I also noticed that when I use some of these Wi-Fi hotspots where you have to pay, sometimes traffic goes to 1.1.1.1. So I wouldn't be surprised about that somehow triggering a reverse DNS query and sending and doing that sort of thing. It might be that it's just that 1.1/16, which is a really dodgy /16 within there. We haven't actually looked into this in that much detail yet.
So do you have the sub/8 detailed? Do you see if it's just 1.1.1.1, or are you?
I think we have the raw data stored away somewhere. But I've just been looking at the data with the DSC, DNS statistics collector stuff. yeah, I think that is exactly the sort of thing that we need to do for the next stage of this research, to go and look at where there are hotspots, go and clean up the data a bit, go and see if the little movements that we saw between the two measurements that I took are really significant, all that sort of thing. So hopefully this was a little bit more useful than just saying, hey, there's a problem. And maybe at the next NANOG we'll have something even more useful than saying, now we've got some measurements. So yeah, hopefully this has been fairly useful.
Any more questions? Thank you very much, Leo.
Thank you.